All right, folks, today we are going to be learning a new couple of stats. They are standard deviation and variance. Okay, so we're going to just take a look at what we already know. Okay, we've already talked about our measures of center being the median and the mean. Measures of spread, some of the things we've worked with. When we talk about spread, it's really a distance measure. So usually there's some sort of subtraction involved. For example, on the range, that's the distance between the max and the min. And then the IQR is the distance between the quartile 3 and the quartile 1. Today we're going to talk about these two, the variance and standard deviation, and then how they really are measures of distance as well. Okay. So to start out, let's talk about breaking down the word standard deviation. Okay, so deviation is kind of like to deviate or move away from, but again, it's a difference measure. Okay, it's a difference of a value in the set from the set's mean. Okay, so we're going to take some number in our set and subtract the mean. Now, our variable here, this is actually the variable for standard deviation, not just a regular deviation. And we'll get to what that looks like here in a minute. But when we talk about standard deviation, our graphing calculator has these measures on them. We can talk about it in two different ways, either with this O with a hat, which is the lowercase sigma, or with a lowercase s. And both of these mean standard deviation, but one is based on a population, the whole group, whereas this lowercase is based on the sample, or the small group, the subset. Now most commonly we're going to use this one because most commonly we're working with a subset of a larger group when we're dealing with problems. Then the variance is just the standard deviation squared. So that's kind of a lot to begin with. What I'm going to do is just show you briefly what the formulas look like for each of these things. Okay, so this is variance and standard deviation. Okay, I like to start with the standard deviation itself, so kind of working backwards here. But standard deviation, there's a lot going on here. We're going to break this down piece by piece so it makes a lot more sense. Okay, but just to give you kind of an idea of what the formula looks like, and then the variance, you just square that. So I like to think of variance as the standard deviation squared, rather than thinking of the standard deviation as the square root of variance. They're equivalent, but our symbol for variance, we use the squared, so we like to work with that standard deviation first. Okay. Now, I told you there were two different symbols because there are two different types with population and in sample. Okay, so I want you to just notice the denominator here is n for the population. If we look at the sample, we instead divide by n minus 1. Okay, really where that comes from is when we're talking about standard deviation, we mean the average distance from the mean. And anytime we calculate an average, we add them all up, that's where the sigma comes into play, and divide by how many. Now, we'll talk about these squares and the square root, why they're there here in a little bit. Okay, but when we divide by how many, that would look like dividing by n. In general, when we have the whole group, that's fine. But when we're dealing with a sample, that n minus 1 just takes care of some error that could occur when we're dealing with only a subset of the whole group. Okay, so if it's a sample, that n minus 1 is happening instead of dividing by the whole total. So, in order for this to make sense, we're going to look at some statistics here. You have an activity sheet that just has a few columns. What we're going to do is two tables calculating the standard deviation by hand here, so we really understand what's going on with standard deviation. So on the front side, we're going to put the dolphins, and I have these dot plots here for you. Okay, so these dot plots are representing the heights of women's basketball players. Okay, so we've got the Dolphins team and the Sweet Peppers. We're looking at Dolphins first. Okay. So right up here, we have in our first column just the x values. That means what are the heights themselves of these dolphins. So the first dot was at 70, so that's 70 inches. And then 71 happened for two different players. And then we're at 73, 74, 75, and then over here we've got a 78, 2 79s, and 180. Okay, you'll notice I didn't write inches on all of these because we can just put that up in the column heading there. Save ourselves a little bit of time. Now, a big idea of today is also learning to interpret some symbols. So let's take a look down here. It says this X bar, and if you remember that's the mean. They will also use in your book and on your homework today the symbol mu for the mean. They're equivalent. So if you see that, it's just another way to say the mean of the set. But then remember sigma means sum, so this says add up all the x's and divide by the n number of terms in the set. So even without this x bar here, we should be able to look at this second half and know that's the mean just by what these smaller pieces mean. Okay, so we got to get better at interpreting what those values are. So let's do it. Add up all these x's here. Okay, so we're taking 70 plus 71 plus 71 plus 73. Go ahead and type those in your calculator. We should get 750. And there are 10 total people on this team. So that makes the mean here for 75 inches. So we can say the average height of a person on the team of the Dolphins would be 75 inches. Well, next up what we're supposed to do, remember x stands for these numbers. We're supposed to subtract that mean from each of them. So first up, 70 minus, our mean was 75, gives us negative 5. What this says is the number 70 was 5 units away from the mean. This negative means it was below the mean because 5 is lower, or 70 is lower than 75. Well, if you remember from a previous screen here, this x minus x bar was the definition of the deviation, or that distance from the mean. But again, we're looking at standard deviation, so just one of the deviations isn't going to be our answer here. In order to talk about the average deviation, we have to find all of them first. So we're going to go through this column and go ahead and do this for all of them. 71 minus 75, all the way down. So go ahead and pause the video and keep subtracting all the way through until you're done here. Okay, we've got our deviations here. Notice I put inches up top here as well because when you take 70 inches minus 75 inches, you still get an inches measured. Okay, 5 inches below the mean, 4 inches below the mean, and so on. All right, but with an average, again, we're going to add them all up. But you'll notice that's not what this next column says to do. That's because when we have negative values and positive values that we're adding together, sometimes the measures end up balancing out. For example, this negative 5 and this 5 would disappear. This negative 4 and this positive 4 would disappear. And if we only focus on those 4 numbers that I just chose out, we would say that our average distance from the mean was 0, but that's not actually true. When we talk about distance measures, we usually think about their magnitude or their size without direction, so no negatives. So that's what the next column does for us, is we're going to square our deviations here so that we can get rid of those negatives. That way stuff doesn't cancel out. Okay, so 25, 16, 16, 4, 1, 0, 9, 16, 16, and 25. Okay. Now, if you remember from when I showed you those formulas, we're going to end up taking the square root because we don't want to change the value of these things. Okay, we just want to get rid of the negative. So we're squaring them now, but we'll square root them in the end here just in a little while. Next up, though, now that we got rid of those negatives, we can go ahead and add them. The sigma says add those squared terms. So go ahead and type those in to get the total here. We should get 128, and you'll notice at the top here, I put inches squared, because if I go take this inch value from over here and square it, I've got inches times inches or inches squared. Now, we said that these ones were the deviations. Over here, we just took the deviations and squared them, so this is the deviations squared. Still not standardized. then down here that would mean this is the sum of the deviations squared, because sigma means sum. Now that we have that, though, we can bring that formula into play that you see on your sheet towards the bottom. We know that this was 128, so we can substitute in this piece here for our numerator. There were 10 numbers in the set, and we're going to do the sample standard deviation. Okay, so that's why this is n minus 1 instead of n, because we're not looking at the whole group. It's a subset. And that would look like 9 then. But we're taking the square root of it. Now in general, we could break this down exactly, but in order for this to make sense as what it really represents, we want to go ahead and just round. And if I don't tell you, I want you to go ahead and round to 2 places or hundredths for standard deviation. Okay, so we're going to take the square root of that 128 over 9. And that gives us about 3.77. Now again, this sum was squared, but we took the square root, so our answer here is inches. Now if this is the standard or the average deviation, it means the deviation is the distance from the mean. So what we're saying here with this 3.77 is, on average, looking at these people in the group, these numbers, we are 3.77 inches away from the mean. Okay, well obviously we're not actually going to hit 3.77. Okay, this 70 inches is exactly 5, not approximately. Okay, but it's an average value. Just like when we had the card value problem a few lessons ago, we had the $5, the $15, the $50, and the $100 gift cards. You were walking out the door with one of those 4 values, but we could still say the average card value was at 11 something. Okay, so this is just a way to compare things in different sets as we can look at this average. All right, now we want to talk about the variance as well. And remember, the variance, we just have to take this and square it. Now, we could square this approximate, but the nice thing about variance is it's always rational. Okay, because here we had an irrational ugly number because the square root of 128 didn't come out nice. Whereas when I take the square root of 128 over 9 and square that, it has to come out nice because those just cancel. We've got 128 over 9. Again, a lot of times it's nicer to look at this as a decimal, but this really we want to not round because that's the nice thing about variance. So unless you're told otherwise, we're going to keep variance exact, but since we are squaring this, we will call it inches squared. But it is also, since standard deviation is a measure of distance or a measure of spread, it is also considered one. Next thing we're going to do is repeat this process for the sweet peppers because, again, it's nice to talk about this in terms of how they compare in spread measures. So remember what this dolphins looks like, this dot plot, and now we're going to go take a look at the sweet peppers. Okay, the sweet peppers here, can you see they're more conglomerated towards the middle here, whereas the dolphins were more spread out? If the dolphins are more spread out with that dot plot, we can say they have more spread, which means they should have a larger standard deviation. Okay, so what we're going to do is see that actually happen in practice here. So once again, we're going to just list our x values here. Okay, we've got 70 and then 74. There are 6, I believe, of those 75. And then 176 and an 80. Once you have those written down, you can go ahead and label the top column inches and add them up just like we did for the last one in order to calculate that mean. You'll notice, hopefully, that this sum was the same as the last one. So even though we had entirely different heights in our set, their sum was the same, which ends up meaning that their mean has to be the same at 75 inches. Okay, so their means are exactly the same here. What we want to do is talk about, well, what about their standard deviations? In order to do that, we look at the regular deviations first. Remember, that's just the distance from the mean. for each of these values in the set. So we're taking 70 minus 75, and so on. Okay, go ahead, pause the video, and I want you to take care of both of this and the next column. Because remember, all we're doing for that next column is squaring these deviations so that we eliminate the negatives. Okay, so pause the video and take care of those for me. Okay, from there, when we add these up, 25, 50, and 2, we've got 52 as a sum here. We can now plug in to our standard deviation formula here. Okay, again, that top number is what we just calculated as 52, the sum of those deviations squared. We're again dividing by 9 using the sample standard deviation and taking the square root of that. This is an irrational number. It's nicer to look at it as a decimal rounded to 2 places. So we'll call this approximately 2.40. So again, it was nice here to look at this in terms of the spread. We said that the dolphins had more spread because there was more numbers that were way out to the sides here, whereas the sweet peppers were all in the middle. So this 2.4 was less than our 3.77 because of those numbers and that spread. Standard deviation squared is going to give us the variance. So we're going to take our square root of 52 over 9 and go ahead and square that. Just gets rid of that square root symbol there. And then when we're dealing with these word problems that are talking about inches, sometimes it's nicer to think of that as 5.7 repeating inches, but then we want to make sure variance always gets that squared label. Again, it's always rational, so that's one of the benefits of talking about variance, but either can be used as measures of spread. Last thing we're going to do, just like with our other measures that we've been calculating, we can let our calculator help us with those. Okay, I told you that we could use our list, our calculator, to actually find these measures in the beginning. So what I want you to do is, let's just, for the sweet peppers, these last ones we're on, put these numbers in our first list. Okay, so stat, edit, and get those typed in for me. So pause the video real quick while you get those typed in. Then what we're going to do is calculate the statistics we normally do the same way. Okay, so stat, over to calc, and then the one variable statistics. We have been skipping over some of these middle values because we didn't know what they were first. But now we realize this S is sample standard deviation, and this sigma is the population. Okay, I told you a little bit the reason we use sample is to account for error. Okay, this is a little bit larger than the population, just in case we messed up somewhere by only choosing a sample of the population instead of the whole group. So the population will always be a smaller value because that has all of your information if it's the whole group, the entire population. So that takes care of a 2.40, but there is no SX squared here, okay, to get the variance. That's something that you have to do a little bit of work for. We want to make sure, since variance is supposed to be always rational, that we get the exact standard deviation here. Well, since our calculator is doing it for us, we don't have this square root of 52 over 9. We don't have that exact version. We just have the decimals as far as the calculator can hold. Okay, this doesn't stop at 5. Our calculator can't just can't show us those digits afterwards. Okay, but what's nice is our calculator stores values in this vars button. Okay, so what I want you to do here is hit vars and then statistics, because standard deviation is a statistic. And then you'll see it on number 3. Now, right now it's not showing the actual value. If you hit enter, it will. You don't need to do this, but just to show you, it brings that up. Again, it's only stopping at the 5 because our calculator can't show any more digits. But then if we hit square it, it'll give us that exact 5.77. Whereas if we were to just take the 2.4 and square it, we wouldn't have as accurate of a number there. Okay, so we always want to use the whole value. And once again, just do this again with me so we remember. We hit vars statistics. You can just tap 5. And then you're either going to use your SX or your sigma, depending on whether it was a sample or a population. Okay, we're going to use sample every single time unless I direct you to use the population. Okay, so you don't have to guess between a sample or population. We're going to assume sample unless we're told otherwise. So take that, square it, and you're done. Jot that down if you need to. You're going to go vars, then stats, and then either the standard deviation that's based on a sample or the one that's based on a population, and then square it for variance. Okay, but that is all that is new. If you have questions when you're working on your homework, please come see me.